Hi everyone. Today I'll explain another interesting example to demonstrate the usage of solver in Excel. In this example, a company is producing two products A and B, and in a week time, totally 50 hours of labor is available. 50 hours of labor is available, and both the products use the same raw material, and totally 100 units of raw material is available to be consumed in a week time. So 50 hours of labor and 100 units of raw materials are available. The problem is adjust the production rate of these two items in such a way that you will get the maximum profit. I have listed few details here. There are two products. Product A fetches 500 rupees profit if it is sold, and B 800 rupees. So B is getting a maximum profit. But for the production of B, 4 hours of labor is required and 3 units of raw material is required. Whereas A, it requires only 3 hours of labor and 2 units of raw material. Now, by knowing these conditions, we can form the constraints like this. So here 3 hours of labor is required for producing an item A. If 1 unit of product A is produced, it requires 3 hours. If 2 units means 6 hours it's required. So 3 times the number of units of A, that will give the number of hours taken for producing A. Because A takes 3 hours, so 3 times A is the number of hours required to produce A units of that product. So 3 times A plus B takes 4 hours. So 4 into B will give the number of hours taken for the product B. So 3A plus 4B, we have only left with the 50 hours. So that should be less than or equal to 50. So total hours required to produce both A and B together, that is less than or equal to 50, because A requires 3 hours and B requires 4 hours. 3A plus 4B should be less than or equal to 50. It should be either 50 or less than 50. So that is a first constraint. We also have another constraint based on the raw material. So for producing 1 unit of A, we require 2 units of raw material. If 2 units are produced, 2 into 2, 4 units of raw material is required. So 2 times A, and that is a raw material required for producing A, and 3 times of B, that is a raw material required for B. So 2A plus 3B, if 1 unit is produced, 2 into 1 plus if B also 1 unit means 3 into 1, so you get 5 units. Totally 5 units of raw material is required to produce 1 unit of A and 1 unit of B. But as the number of units of A and B increases, the number of units of raw material also will increase. But there is a limitation of 100 units. So it should be less than or equal to 100. 2A plus 3B, that should be less than or equal to 100. And also A cannot be less than 0. A should be greater than or equal to 0. Number of units of A, you cannot get a negative value for A, and also for B, you cannot have a negative value. It should be always greater than or equal to 0. So A and B should be greater than or equal to 0. And you cannot have A and B fractions, 2.5 units. You cannot have that. A and B both should be an integer. So this is also another constraint. So there are totally 6 constraints are there. Formulas cannot be typed there in the constraint. So here I need to type the formula. So you can write equal to, it's 3 times A. The number of units produced by A is here. Number of units of B produced is here. 3 is the number of hours of labor required for A. So I'll select this, multiply by number of units of A produced is here. So this is going to be a variable which I need to adjust. So but I'm going to get it here. Number of units of A here, number of units of B here. So I'll select the number of units. 3 hours multiplied by number of units of A plus 4 hours multiplied by number of units of B. So this is the formula. I'll only write that 3A plus 4B. So 3A plus 4B I written. Okay. As a constraint, I should give that 3A plus 4B less than or equal to 50. So that I'll put it in the solver. So this is going to be 3A plus 4B. If I give 1 1 here, you will get totally 7 hours. So for 1 unit of A and 1 unit of B, you require 3 plus 4, 7 hours of labor. So similarly, here I should give 2A plus 3B. So I'll type here equal to, this is 2, that is material. So instead of writing 2, I'll select from this cell. So if I change this value, automatically the formula will change. So I'll select from here, multiply by A plus 3 units, that is 3 units of raw material, multiplied by the number of units of B. So that is a formula for that. In this case, because I put a 1 unit here, 2 plus 3, it's 5. So you got the 3A plus 4B formula written here and 2A plus 3B formula written here. So these things, A, B, that cell directly you can give in the constraint, but formulas cannot be typed there in the constraint. So here profit I should fix. Profit is based on the number of units sold. So if a number of units sold is here, that multiplied by profit for A plus number of units of B multiplied by this profit of B, that will give the total profit. I can type that equal to number of units of A, that is this, multiplied by the profit for A plus number of units of B sold multiplied by the profit for B. So that will give the total profit. So here if it is not there, you will get 0 profit. So if each 1 unit if you sell, you will get 500 plus 800, 1300 profit. Now the number of units of this you cannot produce indefinitely. You have the limitation for the labor hours and number of units of raw material. And that too, there are different constraints. So all these constraints we have written here. Now you can go for solver and we are going to maximize this. I have written a formula here based on the number of units sold and the price we fixed. Now this cell we need to maximize. Profit we are going to maximize by changing only these two values. So A and B you should change, and also the constraints you will apply. So this will go for solver. Now we need to select this objective function here, set objective. Click on this, select that particular cell. Now I selected that particular cell where objective function is kept. Now we want to maximize it, so we'll click on maximum. Then by changing the variables cells, so variables are here, only two cells we need to change, A and B. So you can select that both the cells, then click on the downward arrow, then you need to add the constraints. So I'll add constraints. So adding first constraint is this formula. So I'll select from here that formula, less than or equal to, it's already less than or equal to, it should be 50. So I have written this 3A plus 4B less than or equal to 50. You can add that, and then next is 2A plus 3B, that is here, less than or equal to, that should be 100, less than or equal to 100. Then next we have A greater than or equal to 0 and B greater than or equal to 0. So you can select that A and B here. So I'll select both the A and B together. This should be greater than or equal to 0. So this is another constraint. So I'm including both A and B, both the cells I selected together, greater than or equal to 0. Add. Then again these two cells you should select and say that it should only contain integers. So I'll select that, these two cells I'll select, and we need to select integer. So it is an integer. Both the two cells, these two cells should contain only integer. So now I finished all adding. So now you can click OK. Now you can see all the constraints which you have given. That is, these two cells should contain only integer values, and both the cells should have greater than 0. Okay, these two conditions. And the formula N6 is this formula. Already 3A plus 4B is typed less than or equal to 50, and the N7, that is this cell, formula is 2A plus 3B less than or equal to 100. So I have set the objective, set the variables, and I am maximizing the objective, that is profit, subject to these conditions. Now I will use a GRB nonlinear solution, and now you can solve. Now solver found a solution. So the profit you got 9,800 and number of units also we got. So I'll click OK to keep the solution. So this is the final solution for maximum profit. Company has to produce 2 units of A and 11 units of B to maximize the profit. And that's all for today. Thank you for watching. I'll meet you again in the next video.